So when we talk of heat, heat is a form of energy which travels between 2 points as a result of temperature difference. So let's say we have a metal rod with points A and B. When point A is subjected to heat, let's say point A is subjected to heat, there's going to be movement of electrons. Electrons will move from the point of subjection to heat to point B. That is, electrons will flow from point A to point B. This is because of the temperature difference. So assuming the temperature here is θ1, and then the temperature at B is θ2, the change in the temperature is what we call the heat. So you have to note that temperature or heat moves from highest temperature to the lowest temperature. So it means that the point A, which is subjected to the heat, will have high temperature. So change in temperature will be equal to θ1 minus θ2. Immediately we have difference in temperature within the metal rod. It means that heat is moving. So heat is moving. Let's look at some effects of heat. So the effects of heat, as we all know, heat can change the state of a body. Heat can change the temperature of a body, the color of an object, and then heat also affects the chemical composition. But out of these effects, we are going to concentrate on the changes in temperature. Heat changing temperature of a body. One, and heat changing the state of a body. So these are the main two things we are going to look at, or the two effects of heat we are going to look at. So we have to start. This gives us a broad types of heat, which is two. So we have one, which is we have sensible heat, and then latent heat. So when we talk of sensible heat here, this type of heat energy changes the temperature. It changes the temperature. It only changes the temperature of the body, but the state remains the same. That is sensible heat. So it means that whenever a sensible heat is applied to a body, the temperature will change, but the state of the body, if it is solid, it will remain solid. If it is liquid, it will remain at the liquid state, but the temperature will change, meaning the temperature will rise. When we talk of latent heat, this form of heat does not change the temperature, but it only changes the state. So here, state is affected, meaning the state of the body will be changed, but the temperature is maintained here. The difference between sensible heat and latent heat. So sensible heat, as I already said, will change. It will change the temperature of the body. But latent heat does not. It does not change the temperature of the body. The same way, sensible heat changes the internal energy. It changes the internal energy of the object. But latent heat does not. It does not change the internal energy of the object. the last one, sensible heat, it does not change the state. The state is not affected. State is not affected. But here, state is affected. Good. So let's look at temperature as a broad topic. Let's look at temperature. When we talk of temperature, we mean the degree of hotness or coldness of a body or of an object. The same way as temperature, difference in heat energy. Okay, so when we talk of temperature, it is measured by thermometer. Now, mind you, temperature is a basic quantity, which is a scalar quantity. Okay, so temperature is a scalar quantity, and it is measured by thermometer. So we are going to look at some scales or the degrees in which temperature is measured. So we have the degree Celsius scale, and then we are going to look at the Kelvin scale. Good. So you can be asked, there is a relationship between the degree Celsius and the Kelvin, which is that you can be asked to change the from one unit to the other. So imagine or assuming you are given a temperature in degrees Celsius, so theta in degrees Celsius, and you have been asked to change to Kelvin. This is what you're going to do. It will be, so your answer will be theta plus 273. Then the answer will be in Kelvin. So for example, let's say we have 27 degrees Celsius and we are changing to Kelvin. It means that we are going to get 27 plus 273 to Kelvin, which will be equal to 300 Kelvin. So by change of subject, simply, if you want to change from Kelvin to degrees Celsius, so changing from Kelvin to degrees Celsius, we are going to subtract 273 from a temperature given in Kelvin. So this is how it will be. Temperature in degrees Celsius will be equal to, so we are going to subtract 273 from the temperature given in Kelvin. So Kelvin will be minus 273. So let's say we have 300 in Kelvin. We are supposed to change 300 in Kelvin to degrees Celsius. It will be 300 minus 273, which will give you 27 degrees Celsius. So this is the relationship between the degree Celsius scale and the Kelvin scale. So let's look at the Celsius scale. The Celsius scale. Now the Celsius scale, the reason why we are saying it is Celsius scale is that the calibrations, they are having the unit of degrees Celsius. So whenever a temperature is taken with a thermometer which is having Celsius scale, we write the unit attached to it as degrees Celsius. And then when we move on to the Kelvin scale, we write the unit as Kelvin. So let's say we take a temperature with a thermometer having the Celsius scale or calibrated by the Celsius scale, and then we have 30. We are going to write 30 degrees Celsius, meaning we use the Celsius scale to find that temperature. And then when we had 30 Kelvin, it means that we are using the Kelvin scale. Good. So looking at the Celsius scale, let's take a thermometer. Let's take a thermometer. Let's say this is my thermometer. Now I'm having here to be 0 degrees Celsius and here to be 100 degrees Celsius. Now we have parts of thermometer. So here we have the calibrations. The calibrations. Then this is the, now this point where we have indicated 0 degrees Celsius, we call it the lower first point. Lower first point. Lower first point. This lower first point, it is the temperature at which pure ice will melt. Take note. Lower first point, it is the temperature at which pure ice will melt. And then we have the hand, so this is the 0 degrees Celsius. So when we have the 0, it is lower first point. And then we have upper first point. So the upper first point, which is the 100 degrees Celsius, it is the temperature at which water boils. Yes. Now, this is with the condition, the upper fifth point. It is the temperature at which water boils at STP, meaning temperature and pressure are remaining constant. That is the upper fifth point. Now let's look at the fifth point itself. What do we mean by the fifth point? Now when we talk of fifth point, they are reproducible temperatures which are used to calibrate a thermometer. They are used to calibrate a thermometer. So it means that before we could calibrate this, let's say this is my thermometer and I'm calibrating here 0 degrees Celsius. Let's say here 2 degrees Celsius, 40 degrees Celsius, up to 100 degrees Celsius. It means that I will use the first point, which is the lower first point and the upper first point, before I could get the figures here. So moving on to the Kelvin scale. Now I'm going to reveal some secrets here. Now let's say I'm having my thermometer here. This will always be my thermometer. So here will be 0 Kelvin. Now the maximum Kelvin scale, or the maximum temperature on the Kelvin scale, is 273.16 Kelvin. And then it is approximated to 273. That is why I said when you want to change from degrees Celsius, you just add 273. So the value itself is 273.16. Just as we looked at this Celsius scale when we were having the lower fifth point and the upper fifth point, the same way the Kelvin scale is also having the lower fifth point and the upper fifth point. But with the Kelvin scale, the lower fifth point is denoted by the 0K. Now the lower fifth point is the temperature, that is the lowest temperature at which atoms have the lowest energy. The lowest temperature at which atoms or molecules have the lowest energy. So before I forget, Kelvin scale is also termed as the thermodynamic. Yes, the thermodynamic scale, or the absolute scale, or the ideal gas scale. Good. And then we have the upper fifth point. The upper fifth point. Now the upper fifth point, it is the temperature at which pure ice and pure water coexist in equilibrium. They exist in equilibrium, and it is having the figure of 273.16 K. We are looking at the relationship between two temperatures and their distance apart on a thermometer scale. So let's say we have a uniform scale. When we have a uniform scale, the temperature difference is directly proportional to the distance apart. So the temperature difference is directly proportional to the distance apart. So let's say the temperature difference, denoted with this, will be directly proportional to the distance apart. Let's say the distance apart, let's say it is R. So it means that, temperature difference is directly proportional to R. So if we want to remove the proportionality sign, we just bring our equal to, and then we bring a constant. So this theta will be equal to, let's say our constant is K. So it will be K times R. So here will be temperature change is equal to K R. So by making K the constant, it means that we have temperature difference over R is equal to K. But mind you, r is the distance apart. This r, it is the distance apart. So it means that on the thermometer, we will find the difference between the two distances. We will solve example. So we will find the difference. So this is like also change in distance from the two different temperatures. Good. Let's look at some examples. So let's look at an illustration. Let's say I'm having a thermometer here with a uniform scale. Let's say here is theta 1. Let's say here is theta 2. Here is theta 3. Then here will be theta 4. Let's say here is my bulb. Yes. So it means that it will be reading from here to the side. 0 up to the upper face point. Now the distance, let's say the distance between theta 1 and theta 4 is x. So distance from here up to this point is x. And the distance between theta 4 and theta 3 is y. From the formula, we said change in temperature over the distance apart is equal to constant k. Now this constant means that what we have written here, we should write the same here. So it means that here the change in temperature, we can also write change in temperature over r, which is equal to change in temperature over r. But let's say here is r and theta, so we can say here is theta 1, r1, to differentiate between the two values. So let's say from this point, we have the change in temperature to be this theta 4 minus theta 1. What is the distance separating theta 4 and theta 1? That is x. Out of x is equal to another scale, theta 4 and theta 3 minus theta 3. Out of what is the distance separating theta 4 and theta 3? This is y, and that is it. So with this formula, you could be asked to find any of the variables here. You could be asked to find theta 4 x, theta 4 whatever y, and you are going to use this principle. Above, we're saying that the ice and steam points on an ungraduated thermometers are 120 millimeters apart. So let's draw our thermometer. It is ungraduated. Good. So we have this will be the lower face point, and then this will be the upper face point. So we are saying that the ice point, meaning the ice point is the same as the lower face point, and the steam point is the same as the upper face point. So we are saying that the ice and steam point, they are 120 millimeters apart. So meaning from this point up to this point, the distance is 120 millimeters. Good. And here will be 0 degrees Celsius, the ice point, and then the steam point will be 100 degrees Celsius. Good. Now the question is saying that if the thermometer is immersed in a liquid of temperature 40 degrees Celsius, assuming we are having the mercury thread here, this thermometer is immersed in a liquid of temperature 40 degrees Celsius. Because the temperature is increasing, the thread will move. So let's say it moves, we assume it moves about 40. So let's assume 40 degrees Celsius will be somewhere here. So it means that the distance from the ice point to the 40 degrees Celsius is unknown. Let's say it is y. So let's continue. What is the question saying? Calculate the length of the mercury thread above the ice point. So if we are having 40 here, what will be the length of the mercury thread above the ice point? So from this ice point to the 40. So we are going to look at y, or we are going to find y. So to find y, we said temperature difference over distance of separation is equal to constant, which is the same as temperature difference over distance of separation, but it will be different, meaning here is 1, 1. So let's say temperature difference, we are taking 100 degrees Celsius minus 0 degrees Celsius. So it means the temperature difference between the first points. So we have 100 minus 0 divided by what will be the distance of separation, meaning from this side to this side, which is 120 millimeters. Is equal to constant, the second temperature difference, which is from the 40 to the 0 degrees Celsius. So 40 minus 0 divided by the distance of separation, which is y, we don't know. So let's do some small calculations here. So here will be 100 over 120 is equal to 40 over y. So y will give us 38 millimeters. So guys, looking at these cases, the first one we solved, that was just by the way. Like, you could get those questions in similar. It may be similar figures, it may not be similar figures, but it will be the same case. The structure of the case is the same. Now we have tricky cases. At times you could be asked to find a temperature on a faulty thermometer. Faulty meaning the thermometer is not functioning well. So when it comes like that, we have a formula. So that one too, we are going to use temperature difference. That one is solely on the temperature difference. So here we have temperature difference on wrong scale, or temperature difference on the 40 scale, divided by temperature difference on the correct scale, which is equal to constant. Meaning what you wrote here, the same thing. So here will be temperature difference on wrong scale over temperature difference on correct scale is equal to temperature difference on wrong scale over temperature difference on correct scale. So let's look at example. So with the example above, we are saying that a faulty thermometer records a faulty thermometer, meaning the thermometer is not working well. It is recording negative 0.6 degrees Celsius at the ice point. Oh, funny case. Faulty thermometer at the ice point, it is recording negative 0.0 degrees at the ice point, and 104 degrees Celsius at the steam point. Wow, 104 degrees Celsius at the steam point. A body is known to have a temperature. The body is known. We know a body. We don't know what kind of body it is, but we said it is known to have a temperature of 50 degrees Celsius. So it is known to have a temperature of 50 degrees Celsius. What is the question saying? What will be the reading on the 40 thermometer if it is applied to the body? Meaning that this 50 degrees Celsius is being read on the correct scale. This 50 degrees Celsius is being read on the correct scale. So we are going to bring into concept our ideology of the correct scale of the thermometer. So on the main concept, or on the perfect scale of the degree Celsius of the thermometer, we said here is 0 degrees Celsius, and then here will be 100 degrees Celsius. So instead of the thermometer to read from 0 to 100, it was reading negative 0.6 to 104. This clearly shows that the thermometer is at fault. So we want the temperature here. So we don't know this theta. So we are going to look at this theta. So we are going to use this formula, temperature difference on the wrong scale. So all these at the bottom here, they are on the wrong scales, and then these here are the correct scales. So what will be the temperature difference? Let's say you have 104 minus, you see, you are going to subtract, and here is negative. So on the wrong scale, we are going to have 104 minus negative 0.6 divided by correct scale. This 104 degrees Celsius is corresponding to 100 degrees Celsius on the correct scale, so here will be 100 minus, and this negative 0.6 is corresponding to 0 degrees Celsius on the correct scale, so minus 0, which is equal to constant. So on the wrong scale, we are going to find difference again. So we start from the temperature we are looking for, theta minus 0.6 divided by this 50, because this 50 corresponds to this on the 40 thermometer, minus 0. So here will be some integers. 104 plus 0.6 divided by 100 is equal to theta plus 0.6 divided by 50. So by applying simple cross multiplication, we're going to get theta, which is equal to 104.6 times 50 divided by 100. All this minus 0.6, which will be equal to 51.7 degrees Celsius. So it means that if this body is being read on the 40 thermometer, it will be 51.7 degrees Celsius. So this is the tricky case you will get.